Well, looks like we have some inverse trig functions here, so I guess we need to review the inverse trig function derivatives. So the derivative of arctan, my favorite function, 1 over x squared plus 1, and then the derivative of arcsine, which is also kind of cool, square root of 1 minus x squared. So we're going to use those. I should have made a little bit more room. I think I'll move these over. Those we're going to use for all of these problems on this little mini fake quiz thing. Okay, so first things first, we're going to set this up. It looks like it's a chain rule. And so the outer function is arctan. I just noticed it's a little unfortunate that I used little f of x for my function. So maybe you could think of this as the pale green little f, not the white little f. And then little g, so f prime, 1 over x squared plus 1, and g prime is 3x squared. Just a sec. So we're going to use the chain rule now. So this will be f prime of g times g prime is the chain rule. And so that, in our case, is going to be arctan, f prime. F prime is 1 over something squared plus 1, and that something happens to be x cubed because it's f prime of g, and then times g prime. So 3x squared over x to the 6th. Add the exponents together when you have nested exponents. Very good. Onward. Let's try this one. In this case, this unfortunate situation with the f, but we're using the product rule. F is x cubed and g is arcsine. That means f prime is 3x squared. G prime is 1 over the square root of 1 minus x squared. Comes from our little thought bubble up here. And then we're just going to do fg prime plus gf prime. So there's our product rule. X cubed arcsine. Oh, did it again. X cubed times g prime, which is 1 over square root of 1 minus x squared, plus 3x squared times arcsine. You could probably clean that up a bit, but I'm happy with it the way it is. Ooh, look at this, quotient rule with arcsine and arctan. Low D high. Let's just do it. Do it with the, here, low D high minus high D low over low low. So we'll just do it that way. So arctan, derivative of arcsine minus arcsine, derivative of arctan, all over arctan squared. So these aren't terribly bad. I'm sure I could clean this up a bit, but we're just going to leave it like that. Okay, a few more. So here we have a chain rule. Maybe I should label these. So this is going to be the quotient rule. This is the product rule. This is the chain rule. So over here, this is going to be a chain rule. So f is arcsine, and g is that radical. So f prime is 1 over 1 plus x squared, and g prime is going to be 1/2 times x plus 1 to the negative 1/2. I guess I have to use the chain rule there, but it's such a simple function. Here, I'll put it times 1. That I usually don't bother writing out my chain rule for that. So f prime of g times g prime is going to be 1 over the square root of 1 plus something squared times g prime, whoops. Oh, and the something is g. And then times g prime. Oh, sorry, not 1 plus, it's 1 minus. Hold on a sec. Let's clear that up. Okay, so g prime, which is 1/2 x plus 1 to the negative 1/2. So let's see if I can clean. I suppose I boxed everything else, but this one I want to clean up a little bit better. Let's see, so that's going to be 1 over, let's see, 2 radical x squared plus x. A lot of algebra that I just did in that one step. So let me talk you through it. The 1 cancels with the 1. Ooh, that's a negative x. Good thing I talked you through it. That should be negative x squared minus x. Okay, so I've got the square root of negative x times the square root of x plus 1. And when you have square roots that you're multiplying together, you just multiply this stuff here. How about this? So the 2, you see where that came from. The negative x times the x plus 1 turned into negative x squared minus x. And that's it. Oh, a couple more here. So this one, what in the world? Well, in this case, we're given that g of x is equal to the square root of f of x. And so that means that g prime of x is going to be 1/2. You know what? Just a minute. Let's try again. So g of x is f of x raised to the 1/2 power. So g prime of x will be 1/2 times f of x raised to the negative 1/2 power times f prime of x. So that's using the chain rule. And then we're just supposed to figure out what g prime of 2 is. So g prime of 2 will be 1/2 of f of 2 to the negative 1/2 power times f prime of 2. It says here f of 2 is 4 and f prime of 2 is negative 3. So g prime of 2 is 1/2 times 4 to the negative 1/2 power times negative 3. And I guess I could clean that up. That's going to be 1/2 times 1 over square root of 4 times negative 3. I don't like my 4. And that's all going to be negative 3 over 4, because the square root of 4 is 2. Last one. It says h of x is the inverse of f. So remember that the inverse function, derivative of the inverse function, is 1 over the derivative of the function evaluated at the inverse function, which is really confusing, but let's go ahead and see if we can sort this out. First things first, we need to know what f prime is. Oh, I see. Yeah, we don't have any function, we're just gonna do numbers. So since we're just doing numbers, let me just make a little bit more room. So I want h prime of 4, and h is the inverse of f, so I'll be evaluating the derivative of f prime at 4, which means that I will be doing this, but putting a 4 in here. Now for the hard part, well, it's not that hard. I need to know the inverse function at 4. Well, here's the deal. Since f of 2 is equal to 4, that means that f inverse of 4 is equal to 2. That's what inverse function means, is the inverse. So this will be 1 over f prime of 2. And then we can look up f prime of 2 is negative 3. So that's going to be 1 over negative 3. And that's it. All right, hope this helps. Don't forget to smash that like button and subscribe for more videos like this.